problem, this is again basically testing out our calculus skills, but in this case, basically we're instead of taking derivatives, we're actually going to do integrals. Okay, suppose I tell you the acceleration of a particle is given by at is equal to 4t cubed minus 6t squared meters per second squared. Meters per second squared, yes. Find the velocity as a function of time if function of time period, assume that at t equals 0, it had a velocity of minus 6 meters per second. Okay, and B, find the position as a function of time if it starts out x equals 0 at t equals 0. All right, well, hopefully that will clear things up. Okay, so let's just do it. Okay, so find the velocity. So the velocity is equal to the integral of a of t dt. All right. Okay, so if we do this, basically what we're getting is this is the integral of 4t cubed minus 6t squared, right, dt. When we apply this integral, recall that the integral of ct to the n is equal to basically c over n plus 1 t to the n plus 1 plus some constant d, where c, d, and n are constants. Okay, there's an exceptional case of n equals minus 1. All right, but anyway, so we'll discuss it in the class. So when we do this, basically just look at this thing. This c in this case is 4, n is going to be 3, so it's going to be basically 4 over 3 plus 1, okay, t to the 3 plus 1 minus this term right here. C now is minus 6, right? Divided by n plus 1 is basically 2 plus 1, t to the 2 plus 1, okay, plus some constant. I'll call it d now, right? So this is going to be equal to basically 4 over 4 is 1, that's t to the 4th, minus 6 divided by 3 is 2, t cubed. Okay, so that's very nice. All right, so let's basically then that plus d. Okay, so this is what's called an initial value problem. So you need to know the initial value. Initial value is basically that v at 0 is equal to minus 6 meters per second. What's that equal to? Well, that's equal to basically 0 to the 4th minus 2 times 0 cubed plus basically d. And so this is equal to, actually I shouldn't call this d. I should really call this v0. Right? And so basically what you're going to get, this is going to be 0, that's going to be 0, that's 0. And so you have basically v0 is equal to minus 6 meters per second. And so when we write down the final answer, v as a function of t, that's just going to be equal to t to the 4th minus 2t cubed minus 6 entire thing meters per second. Beautiful. That's part A, all right? And part B, we recall that x of t is equal to integral of v of t dt, all right? We just solve v of t. That's just this guy right here. This is integral of t to the 4th minus 2t cubed minus 6 dt. Right, solving this integral, recalling this particular rule, this is going to be basically 1/5 to t to the 5 minus 1/2 t to the 4th minus 6t plus x0. All right, and we know at x0 is equal to 0, so that is equal to 0 is equal to 1/5, 0 to the 5th power, minus 1/2, 0 to the 4th power, minus 6 times 0 plus x0, and this gives you x0 equals 0. And so the final answer is x of t is equal to 1/5 t to the 5th minus 1/2 t to the 4th minus 6t plus 0, entire thing, meters. Okay, beautiful.